Yeah, hello and welcome everyone to this session. My name is Stefania. I'm a product manager at Databricks working on Spark Connect and a couple of other topics. And I'm here with Martin Grond. He's my tech lead counterpart on all of these topics. So I hope you've all heard in the keynote that what Spark Connect can do. We'll go a bit more into detail in this talk. But before we start, I want to ask a couple of questions. So who of you develops with Spark locally? Oh, many. What about the data? How do you manage the data? Who has a synthetic data set locally? Okay, what do other people do when you develop locally? Somehow figure it out. Okay. And who uses Apache Livy or JDBC in applications to connect to Spark? Okay, cool. Yeah, so all of these, so today developers have a couple of requirements which sometimes are a bit hard to accommodate in Spark. Like one of it is to be close to the data during development. So, I mean, ideally when you develop your code, you want to test it with the right data. And if you develop locally with Spark, for example, that's a bit harder to achieve. You also want to have like an interactive experience so that you can do a bit of exploration while developing, like kind of probe the data, see whether what you're actually coding is going to work. And then ideally, you have a high production fidelity. What is a high production fidelity? Ideally, you're very close to production, which is typically where your data sits, right? And then there's this whole class of other requirements where you actually would like, I mean, every application today is a data application, so ideally you just want to interact with Spark from any type of application, but also from different types of languages. Up until Spark 3.4, that was actually really hard to achieve. If you wanted to integrate with Spark from like your data application, you had a couple of possibilities. You could use Apache Livy, or you can use JDBC to connect to Spark via SQL, but there wasn't any other way to do like remote connectivity to Spark. If you want to develop interactively your Spark workloads against your remote Spark cluster, that was relatively hard. You had to be very close to the REPL in order to do that. And finally, if you wanted to use languages that weren't the kind of like Spark native languages, there wasn't really an option because you had to have JVM interoperability. But with Spark Connect, we addressed many of these pain points and basically introduced remote connectivity to Spark. So what you get is a thin client which you can use as your kind of like narrow-waist API. Is based on like a declarative approach with the DataFrame, which you can use to use the full power of Spark within your application. So you can connect from any application, you can develop from any IDE, and you can create clients for any programming language. So let's look under the hood, like how that actually works. So what does that mean, a client, and so on and so forth. So it all starts with like a declarative API. In PySpark, that's the DataFrame API. In the Scala client that we're currently developing is the DataFrame and the Dataset API. So what do you need to do if you want to implement a client for Spark Connect? What you need to do is basically, like the Spark Connect protocol relies on unresolved logical plans. So what you need to do is to translate into unresolved logical plans and then send those via gRCP to the Spark server. On the Spark server side, there's a single point place of analysis, which is the analyzer, where your unresolved logical plans, they get analyzed, they get optimized, the query gets executed, and once all of that is done, the results are streamed back. The client doesn't need to know any about that. The only interface that you see in order to, or that you use in order to like send your queries are unresolved logical plans. The result is streamed back via gRPC using Arrow, and you can use the result on the client side. So the whole protocol is completely language agnostic. And you can implement such clients for any language. I mean, with G8 PySpark, Scala is on the way, and the community has already picked up a Go client. and we hope that there will be many other contributions on that. So what we'll do in the rest of this talk is first show you a couple of client applications, like what can you do on top of Spark, and then we'll also talk about server extensibility. So, but before we do that, I quickly want to show you how you can get started, because you think, oh, this is a new API, a lot of code changes, but it's actually really simple. You simply install PySpark into your virtual environment, and then instead of creating a regular Spark session, what you do is you create a remote Spark session. You need to define a connection string which basically specifies your remote Spark cluster to which you want to connect through the Spark Connect API, and off you go. You can build your application. And just to show you like a little example, it's really only the session. This is like your regular DataFrame, PySpark DataFrame code. The only thing that changes here is that we actually build a remote session, and then it's pure Spark. Yeah, and so with that, you can embed PySpark and also other clients in like any applications. You can use it in your IDE to do interactive development. You can build new SDKs and new connectors. I already mentioned that the community has started to work on the Go client. We at Databricks, we have Databricks Connect, which is our product for remote connectivity to Databricks. We have based this on Spark Connect now. And we've also built a couple of example applications that showcase how you can actually just build on Spark very easily. And now I give over to Martin, who will walk you and demo like a lot of these examples.
All right, thanks for that. So what I'm going to do now is basically we're switching from the more high-level part of the talk to the more kind of low-level pieces. We start like with traditional examples, and then later I'm going to really go deep down into some of the more internals of Spark Connect that you can use to basically extend it in the ways that you want. So if you've been in our talk on Tuesday, you might know this example, but I'm going to repeat this here. You know, you've heard over the last couple of days, you know, medallion architecture, gold, silver, bronze, different feature layers and whatsoever. So, you know, imagine that you have this kind of ETL process, you want to test it, you want to basically build this from your IDE. So how would this look like, you know? What you can do with Spark Connect, essentially, it gives you the ability to develop these kind of these processes like from the IDEs that you're used to, yeah? And you can test them and run them directly from there. So this is a screenshot from PyCharm. I'm not going to demo PyCharm because that's kind of boring. I mean, like everybody that has ever run PySpark like knows well, I mean, this works, except that here I can connect to a remote cluster. I'm actually going to show you the same in IntelliJ. And why this is so cool is actually, all right, let's see if this starts. If I click again, it does. All right. So why this is so cool is because in this case, I'm connecting to a Spark cluster that Spark, basically just local cluster that runs locally. I'm stepping through my application. I can debug it. I can interact with this data frame. And you know, I think this is actually the cool part. Every time, you know, why do people use notebooks? You know, it's like always this kind of interactivity when you're working with your data. And you know, sometimes you have this problem. Oh, I need to debug this. Sure, unit tests are awesome, but then there's always this question of like, did you cover all the cases? Do you really know what's going on? Do you know what's in the data? And this is the amazing part about being able to debug essentially your use cases directly from an IDE, because you have the power of the development environment that you're used to, and at the same time you get the interactivity and the flexibility of Spark to be able to reason with the result set, reason about the result set, and really make it very easy and convenient to use. All right, so in this case, we're debugging through this, and yeah, as you can see, basically I'm always like using this kind of variable explorer to really interrogate the result set and like check what's going on, and that's really convenient. All right. All right. So again, applications is one way. It's like just on top usage, you know. But then the question is like, okay, what kind of connectors and language SDKs exist for Spark Connect today? On the Databricks side, what we offer is Databricks Connect, which is essentially a very convenient way to interact with the Databricks Lakehouse. So it gives you the ability to directly leverage all of the features that we provide in terms of governance, security, authentication. So if you're using single sign-on or auth, like this is all integrated with our SDKs. But the cool part is that under the hood, it's still the same open source format. It's still the same open source protocol that you can use from anywhere. So you don't have to use Databricks Connect. This is really just our wrapper to make it easy and convenient to use. And this you can then use to build like not just from IDEs and notebooks, but you can build data applications, partner integrations, and so on. All right. Then on the same side, we have new SDKs coming up. So there was a discussion on the Apache mailing list about like, hey, can we have Go support? And in this case, what we did is, so we started the project. There's a brave soul that like started the process of like implementing a Go client for Spark Connect. So this is native. There's no JVM dependency. It's really just Go and Arrow and the protobuf essentially to make it work. And then there's this other piece, you know, like customers and users have always asked, hey, what about Spark R? And like, how can we use R? Like, it's still, you know, every now and then there are certain customers that really have the need for it. And the folks from Posit, they developed this awesome library called Reticulate, which is basically a Python wrapper. And what this does, it allows you to use Spark Connect from R directly. You don't have to deal with like Java bindings and like figuring out like how Spark R works. You can simply connect to your, I mean, in this case, I was using DB Connect, but same way it goes for Spark Connect. You configure your connection, and then you have all of the API functionality available for your, from a PySpark session, and then you can just use all of the R features to plot something. And I mean, again, this is a very simple example. This is like nothing fancy. Let's see, I think. All right, I actually have a video for this here. So this just walks you through. So I'm loading ggplot. I mean, there's always this kind of discussion, oh, ggplot's so awesome to use for plotting. I'm now using, I import the Reticulate library, which starts a Python process in the background. And again, the Posit folks have done an amazing job in making this available. And then I import the Python packages. And that's actually the interesting part, is that how conveniently they wrap the Python modules directly to be called from R. And then I can use this dollar notation to create the necessary instances. And please, if you see like weird stuff in like this R code, like I'm not an R person, you know, this is like me Googling for 5 minutes and asking ChatGPT how to write R. So if this looks like weird, this is because of that. Wow. So, and we've been in contact with the folks from Posit, and they've been working on like integrating this into dplyr. So to really make sure that there's like a more R idiomatic way of interacting with the data. But you know, this is, we said, hey, you know, this is so awesome. Let's just show this, you know, like in a demo, because it's not meant to be like the perfect way of interacting with R, but you know, it's one way. You know, like you can get started today. You don't have to wait for this library to appear. And as you can see here, I'm just doing spark.range10, and then I get to the data. Now, the next thing I'm going to do is I'm basically use a sample data set from Databricks, from my cluster, load the data, and will now try to plot this. So what Reticulate allows you is it basically converts the result to a pandas data frame, and the pandas data frame internally uses Arrow, and then they convert this into the R data frames. And now, as soon as I called like the dataset to pandas, I basically now have all of the typical R functionality available. So I can call summary, I get the insights about the data, and at the same time, I can just plot the data in the same way. So I'm using, I'm creating a graph using ggplot, plot the taxi data frame, define the axes based on my data set. And I should have typed faster here. And we'll now plot, of course, geomean point, like typing is hard. All right? But you know, like, it wouldn't be really a nice demo if there's not some kind of machine learning in there. Machine learning AI, sorry. And so I was always saying, hey, you know, like the last time I did AI was like linear regression. So I Googled like, okay, how to use linear regression in R. Hey, why is this not, this should go further. Oh, it's loading, of course. Yeah, so the next thing that will come in this video is actually using like the built-in R functionality to basically do linear regression on the plot, and then shows us like a nice line in there. So I will just skip this because it doesn't look like this is gonna load any faster. All right, so the other thing is basically this kind of data application development. It's again, it works very the same way. You know, like the one thing that you should take from here is like, if you're used to basically creating a Spark session, it works the same way in Spark Connect, except you're no longer running locally. This is the 4-line Dash application that I was able to come up with. It's really just, very, very simple. It starts a Dash app, creates a table, and this is it. And then like all of these examples are on GitHub, like it's on github.com/Databricks-demos-dbconnect-examples, so many dashes. And then you can use them, like all of the code is for you there to check out. Once the slides are online, all of these links are obviously clickable. There you can see, and on in this example repository, you find even more applications in Scala, in Python, and like different use cases for that. All right. But like you've seen Reno today talk about PySpark AI, which is like the mouthful of English SDK for Apache Spark, which is really awesome. And I mean, once I used this the first time, this is just mind-boggling how much this is going to transform the way that you're working with PySpark. Like if you're thinking today, again, like group by and ACKs and window functions and specs, this is going to completely change your life. So how this works is, I mean, all you do is basically say dataframe.ai.transform, and then off you go. Because I would think that you would not believe me how this works, I basically have a live demo. Of course. Wait, where's my mouse? I was told, there's it. All right. So let me quickly check if everything is still running. Yes, it is. All right. So this is the application. Please excuse my weird skills in using Plotly as well. So every time I click something, it goes back to my Databricks cluster, it runs a query, and comes back with a result. And now, I was thinking, okay, so what would be filters? Like, again, like, I don't know really the data set, I don't know the columns, but what I can type here is basically show all rows with drop-offs in Manhattan. So what this does is essentially use LangChain and PySpark AI to go to, all right, now it's getting fancy. There we go. It goes to OpenAI, generates the code, generates the plan for it, and then I get my result, And what I can do as well is saying, okay, we always say the people in the financial district, they're really hardworking. So let's see how hard they're really working, because you want to see show only the pickups in the financial district after 10 p.m. Well, because hardworking people, they leave the office like really late. All right, let's see. So again, LangChain, OpenAI, generate code, and then comes back with results, and off you go. See, not so many people really working that late. So, all right, cool. You get the idea. And I mean, look, this is like, you've seen the plotting example, it's mind-blowing. Try it out. It works with Spark Connect, it works with DB Connect. This is going to be a game changer. All right, live demo worked. Hey, 1,000 points. All right. Now comes the like really, really nerdy talk, which is the part about, all right, Spark is awesome, data frames are awesome, and then usually, like if I would ask in this room, like how many people use still an RDD somewhere in their code, like sometimes people really don't, they feel like, I shouldn't really say yes here because like RDDs are kind of like, But I mean, they will always be there, like they're not gonna go away. There's like application logic that has been written like 15 years ago, and like what do? Like you can't just throw it away. However, as we said in our Spark Connect proposal, was like, hey, we don't want to support RDDs because they're very low-level feature. They're not really useful in this kind of declarative way. So that's why we said, okay, like, how do we build something that says, I want to have the ability to extend the protocol of Spark Connect with new features. And a new feature might be just the ability to call an RDD, basically building kind of a data frame front end to an RDD, to your custom application logic that you have in your server. So okay, so dataset, data frame is just the beginning, but now I have these kind of new APIs, like how do I connect them to Spark Connect? And our goal with Spark Connect was like extensibility, compatibility, and stability. So, exposing the Java code for your RDD directly is like always hard because now you're shipping something to the client that you might not really want to ship. So what we came up with is a way to give you extension points in the Spark Connect protocol that allow you to wrap basically your custom logic with extensions that you can then call directly from Python, from R, from Scala. And the cool part is you only have to write the server once, so to say, and then it's very easy integration, very little integration actually into the clients to make it callable. because I believe that you wouldn't, because I think that you wouldn't believe me, I actually said, okay, I'm going to walk you through an example. So this is, again, it's really just nothing more than like a tiny Scala class and a little bit of a proto message, and this is all that you have to implement. All right. What I'm going to do here is, everybody loves the Spark UI, well, because it's awesome, it's like very detailed. But how often do you think, wouldn't it be awesome if I am in a notebook and I could ask for, give me please a data frame that contains all the queries that were executed? You know, like system tables. I mean, again, I'm a database person. I grew up in the relational database world, and the lack of system tables in Spark drives me nuts. And it's like, I mean, I can't be the only person. Right? I'm still waiting for people like to actually fix this problem. So that's why I said, okay, can I build, like in 200 lines of code roughly, like a SQL query history data frame with Spark Connect? All right. How does this work? So the first thing that we need to do is we need to do something on the server side. Well, because Spark doesn't really expose the data frame in any way, the history in any way, except there's this thing called the shared app state. The shared app state is part of the Spark context, and you can interrogate it about like what kind of queries are running. So what this means is we're basically creating two new entries in Spark, which is like a plan node, a logical plan node, and a physical plan node. And what the exec node does, it's essentially getting the active session state, then gets this, the shared app state, and then iterates over all of the execution in the shared app states and creates a sequence of eternal rows. And now all I need to do is like, okay, now I have this already, so how does this look like? So now the next thing is, Spark has a lot of extension points for this, and they call this, there's this Spark strategies. And in the Spark strategies, I can essentially say, I want a new planning strategy, and then I inject like planning rules into it. And for my planning rule, I just say, if I observe this show SQL executions plan node, then map this to this exec node. This is, I'm not hiding any code, this is like literally all. And you find the example on GitHub, it's like 200 lines, very easy. All right, so how does this look, you know, like just from Scala? So far we haven't done anything with Spark Connect. This is really just the beginnings of like doing something in Scala. So I'm calling shim of rows. Shim is really just something because unfortunately of rows is a private API in Spark. So I had to like wriggle my way around this. And basically shim of rows, Spark session, my plan node, and then I can select from it. You know, like it's already data frame, I can use it. Of course, I have a video for this. So right, okay, I start the Spark shell. The long command is because I have to provide SparkConf for my planner strategy classes. I have to provide the jar file and like conf to just load this. I import the necessary classes. All right, and now I can essentially create the. I'm reading a file now here, so that I'm actually having some SQL execution that I can see. So I'm reading a temp file that I found somewhere. Again, taxis because they're awesome. All right. All right, and now I run an actual operation because so far nothing really has happened. So I run an operation on it. And so now there should be two actual queries that have been run. One is like the aggregation for the count and another one for the select. And now I'm creating basically the SQL execution, SQL E kind of data frame. So basically I'm creating my shim of rows. I think this will not because I'm missing the Spark session there. All right. Just give me 1 second. Okay, I inject the Spark session. And now I have a data frame that I can show. Count first. All right, I have 4 entries. And now I can basically, it behaves like any other data frame. And this is already, you know, just this is already kind of like, ooh, this is awesome, this is an improvement. Except that, well, I still have to use the Spark shell here. Like, it's not really remote. All right, so how do we continue from here? The next step is basically I need to integrate this into Spark Connect. How I integrate this into Spark Connect is basically I'm creating a new relation type in Spark Connect called app state relation that is completely empty. It's really just a hook for the server side to understand I'm requesting this particular state. And then I'm writing a relation plugin that contains nothing more than these couple of lines, which means we encode extensions as protobuf any values, which means that when the planner observes that, oh, I have a protobuf any here, it tries to match, like, do I know any class that can deal with this kind of message type? And so all my plugin has to do is basically check, is this any type of my particular class relation, and then returns an option of logical plan, and then I can just execute this. And now the next step is, so how do I use this now from Python? It's very easy. So from my protobuf message, I generate the Python code, which is what's highlighted there on the top. And then I'm creating a logical plan node in my Python client, and then simply perform some monkey patching that injects the SQL execution functions into the Spark session instance. And once I've done this, I can now do the same. So again, I start PySpark, this time with all of the magic jars that I need. And as you can see, it says like client connected to Spark Connect server at localhost. So I have a regular Spark Connect session here. And now, all right, because obviously my code lived in different directories, I had to monkey a little bit with the Python path. So I'm importing the app state. Once it's imported, it's already injecting itself into the Spark session. So, and as you can see, like I called this method now in the Python Spark session. It's returning me the instance of the server side. Right now, I'm doing the same thing as I did before in Java. I'm reading the file from disk, and I'm running the count. Okay. And now I'm showing the SQL executions. And I'm always selecting here because it's just like this much text, which doesn't fit on my tiny little terminal. And as you can see, it's already like the analyze plan, for example, is run like every time when you just like, when it tries to inspect the schema of a data frame, it runs an analyze actually of the actual operation and allows you to essentially work with this. All right, and what you've seen now is like, again, it's like 200 lines with Scala and maybe like 50 lines of Python code. You have a complete example of like how to build a custom extension with Spark Connect, calling arbitrary logic on the server side without forcing you to bring this arbitrary logic to the client and like using it in the same declarative way as you would use any other Spark data frame operations. There are two more related talks that's happening today, unfortunately at the same time. One is Yukjin is an awesome contributor to Apache Spark on the Python side, is going to give a talk about like using Python with Spark Connect. And then there's another talk, unfortunately at the same time, how to use the English SDK for Apache Spark, boosting development with LLMs. So with that, thanks a lot for your attention, and we're using the last 10 minutes for questions. Thank you so much.